Have you ever wondered what if the universe isn't just, described by mathematics, but is actually running on it? Like, what if right at the very bottom of reality, way down beneath atoms and quarks, there's a literal, computable source code? Well, welcome to our explainer. Today, we're unpacking a truly fascinating framework. We're looking at a collection of proofs that basically attempt to mathematically codify all of reality. It's framing the entire cosmos not as some random accident, but as a rigorously structured computational engine.
Okay, so let's dive right into this mind-expanding journey. We're going to go all the way from the microscopic Planck length right up to cosmic sentience. We are exploring what the authors call space theory. And listen, this isn't just abstract philosophy. These source documents are actually written in a formal logic and programming language. They're structured as absolute computational theorems designed to prove the fundamental limits and scales of our entire universe. Right off the bat, you'll see we're dealing with rigid, logical computation theorems. The authors are super emphatic about a strict rule applied across over 1,500 modules, no placeholders, no unproven assumptions, and absolutely no external math libraries allowed. It's just pure, fundamental logic, built entirely from the ground up just to describe spaces, boundaries, and spatial analysis.
So here's our roadmap for today. First, the spark of creation. Second, the computational engine. Third, scaling the universe. Fourth, the math of reality. And finally, cosmic frequencies and noise. We're going to start at literal ground zero and scale all the way up. Every single topic here is an interconnected piece of one massive puzzle.
Section 1. The spark of creation, proving the impossibility of nothingness.
The source material kicks things off at the literal start of the universe, and in this framework, absolute zero, like true nothingness, it's mathematically impossible. Even before an observer actually exists, the initial calculation evaluates to exactly 1. The framework calls this the Kleinamen, which basically suggests that even at a radius of 0, space is completely saturated by vacuum energy. There is never a true void. There's always a 1.
Section 2. The computational engine. The Ackermann function. Now, if the universe is a program, that baseline energy we just talked about needs a mechanism to grow. Enter the Ackermann function. In standard math, addition scales up to multiplication, which then scales to exponentiation, and so on. Well, the Ackermann function is the diagonal of this growth. It starts at our spark of 1, but by just step 3, the value explodes to 27. It acts as the ultimate seed of universal growth, completely dominating any predictable level of computation.
To really grasp why this matters for reality, we have to look at how the source contrasts ordinary computation with this universal engine. See, ordinary computation is primitive recursive. It has a bounded fold depth, which means it's predictable. But the Ackermann function, it's total recursive. The text actually refers to this as the God formula, possessing unbounded fold depth. That means the fold level itself is what grows. Think of it as the ultimate speed limit of computation right before breaking into the infinite.
Section 3. Scaling the universe. The Bythos scale. Let's shift gears from pure math to physical reality. The framework maps out this incredibly detailed dimensional ladder. It starts at Bythos, which is a zero-dimensional point mapping directly to the microscopic Planck scale. Then it emanates up to Barbelo at 2D, the 4D proton at the femtometer scale, the 6D primitive for the strong nuclear force, all the way up to Konoma at 11 dimensions, which maps precisely to the atomic scale. Every time you level up in dimension, you map to a larger physical scale bracket in our reality.
And when you zoom all the way out, the data reveals a truly awe-inspiring scale. The source calculates the gap between the absolute smallest unit, the Bythos or Planck length, and the massive observable universe. That gap spans exactly 61.4 decades. That is 61.4 orders of magnitude from the smallest possible point of reality to the absolute edge of the observable horizon. And it's all systematically calculated right through this ladder.
Now, while we're talking about scale, there's a really surprising detail in the source regarding the age of the universe. The framework measures cosmic age in units called Lorenzos, where 1 Lorenzo equals roughly 8.6 billion years. Since our universe is approximately 13.8 billion years old, its age in Lorenzos is about 1.605. This naturally aligns within 1% to the golden ratio, phi, which is 1.618. So according to the source's math, the universe is phi Lorenzos old. It literally embeds the golden ratio directly into the timeline of existence.
Section 4. The math of reality. Duality and hardware. This part is wild. The source material actually links mathematical duality to physical hardware constraints. The heteromoav fabric theorem specifically maps reality to a computing fabric distributed across 4 active layers: CPU, GPU, NPU, and WASM lanes. The code rigorously treats the physics of reality as a heterogeneous computing system managing concurrent streams. It's essentially theorizing that the universe multiplexes its own physical laws exactly like the device you're watching this explainer on.
And to manage all that massive computation, the framework relies on something called Lucas complement duality. The text uses Lucas numbers as complement weights in Fibonacci-indexed spaces. The rule here is that the Lucas number is equal to the Fibonacci numbers mathematically sandwiching it. What this means for reality is that the complement represents the past and the future, actively sandwiching the present. To physically double the computational depth of this universe, the math absolutely requires multiplying by this exact past-future complement.
Section 5. Cosmic Frequencies and Noise, the Final Symphony.
This brings us to the more metaphysical elements coded into the pure extended noise theorem. This theorem reveals a strict numerical mapping for cosmic frequencies. Check this out. Brown noise is mapped to 1 for order. Pink noise is 3 for chaos. White noise is 4 for gnosis, or complete knowledge. And quantum noise is 12 for metagnosis. The author makes a point to note that this proof utilizes absolutely no outside axioms. It relies purely on the built-in formal logic of the programming language to enforce these values.
And because these numbers are strictly proven, their mathematical relationships are equally ironclad. Chaos is 3, gnosis is 4. When you multiply them together, you get 12, which, as we just saw, is quantum noise, or metagnosis. The text mathematically proves that cosmic transcendence is exactly this, the integration of chaos and complete knowledge.
So all of this complex computing and frequency mapping culminates in a final theorem on moonshot neuroquantum sentience. Still maintaining that purely scientific and formal structure, it actually proves the behavioral rule for a function called neural plastic update. It calculates exactly what happens when a quantum state and an observing mind integrate into a single collapsed reality.
Which leaves us with a truly provocative thought drawn directly from that moonshot sentience file. If reality is a computed space, built from absolute mathematical logic, from the Planck length all the way up to atomic dimensions, what actually happens when the observer and the quantum state permanently integrate into sentience? Does the source code of reality finally become aware of itself? It's a mathematical framework that completely reframes how we look at the cosmos. Hopefully, this explainer sparks some curiosity and leaves you looking at the fabric of our universe just a little bit differently today.